okay? And we have the integral from 0 to b, from k e to negative kx dx. Perfect, perfect pick, thank you. The same idea, let u be negative kx. Can anyone give us du?
Try minus kx dx.
So let's differentiate this. Of course, k is a constant. Of course, b is a constant. So when we differentiate this, what do we get?
Negative k dx.
Very good, awesome. So I have the k, I have the dx. Oh, I have to make up a negative. No problem. Multiply by -1 twice will not change anything. So now I have negative k and dx that make up the du. Have to keep the negative outside. So I have e to u du. This is e to u, and du is this, this, and this. But now careful. Please plug in 0, and let's find the lower limit for u.
Minus k.
How much is 0 times negative k?
Right.
0 times negative k. So we are stuck on 0 times negative k. Can anyone unstuck
That's
us?
0.
Of course, of course. Okay, so now let's plug in b. So how much is negative kb? It's negative kb. Good. So then I have negative e to u from 0 to negative kb. -1 stays outside. I plug in negative kb. Minus, when I plug in 0, we know that's 1. And that's it. There's nothing else to it. How do we feel about this, these indefinite integrals now?
Why we use the negative every time we use it over there? I cannot use only one time?
So you're talking about these negatives?
Yeah.
So this is exactly the same idea with here. Here I needed to make up a 4. So I multiply by 4 and divide by 4. Here I needed to make up a -1. So I multiply by -1 and divide by -1. But when I divide and multiply twice is the same thing.
Okay.
So I needed to make up a factor of -1. Here I needed to make up a factor of 4. Another way, these are too simple, I think, to solve for dx. That's my opinion. But you can solve for dx. So then dx is dt over 4. So that's where this 4 is coming from, if that's easier for you. For these simple integrals, I don't teach that method. But if somebody teaches you that method to solve for dx, it's the same thing. So dx is dt over 4, dt over 4. It's up to you, but they're too simple to even go through that complicated step in a way, but it's up to you. If the numbers, if dx is there and just a number needs to be made up, it's not a problem. Multiply the top by 4, divide the bottom by 4. That's what I did here. -1 at the top, -1 at the denominator. It's just the same thing with multiplying twice by -1. So -1 times -1 is 1. I didn't change the problem. I only needed the negative k, -1 times k times dx, -1 times k times dx to get the du. But once I multiply by a -1, I have to multiply again, or multiply and divide, because otherwise I change the problem. If I don't write this, I change the problem. But if I write this, I didn't, because this is 1. So I needed to incorporate a -1 k and dx in du. And then I copy this. I have to. You can always say, for this particular definite integral, you cannot check. You cannot check with a calculator. You cannot check in any way. But I guarantee you that if you differentiate this, you will get that -k with a negative in front, which will take care of it. Good. Other questions, or can we look at the word problem? So let's look at an application now. Okay, so let's take a look at this one, the marriage rate, because the function looks awful. So it looks awful. So we have m of t. The marriage rate in Nevada is approximated by this function, 38.045 times e to -0.045t. And where m of t is number of marriages per 1,000 people, number per 1,000. And t years after 2010. So t equals 0 represents 2010. Find the total number of marriages. Total number between 2010 and 2015. Okay. So we know what to do. So 2015 means t equals 5. So the integral from 0 to 5 from this ugly function. So 38.045 times e to -0.045t, of course, dt. The function is in t, I have to have dt. Function is in x, I have to have dx. So it looked ugly and difficult, but it's not. So this number stays outside. So remember, we can use a substitution rule, but we did this a long time ago. -0.045t over -0.045 from 0 to 5. So when I plug in, so this number will stay outside. I'm not going to divide it right now. So I have -38.045 over this number times e to this with -5, 0.045 times 5, minus
Where'd
when
you get negative?
It was negative. Let me check. You mean this negative?
Yeah.
This over this.
Okay.
Good. I thought that I copied the function incorrectly. Is that what you said? Or this negative?
No,
So
that
when I
one was
divide these two
different.
numbers, I get a negative number.
Yep.
So minus when I plug in 0, I get 1. So this needs to be approximated. So, because it doesn't mean anything. And we can also check. So I have -38. I need parentheses here. -38. I mean, the negative can stay outside, but I need parentheses. 38.045 and divide by 0.045 and close and open under parenthesis e to -0.045 times 5, close that parenthesis, and then subtract 1. And that's a total number. It says, find the total number of marriages per 1,000 people between 2010 and 2015. So 170 per 1,000 people. So you can also do this as I showed you last time. I think it was number 9. Yes, it was from 0 to 5. We have to get the exact same answer.
How did you do that?
Math 9.
Okay.
Math 9. Let me know if you don't find it. 38.045. And E, where is my E?
I think I'm looking for that too much.
Good. So negative.
My
Point.
calculator's too old.
You really don't need it, honestly. The problems will be simple enough. So we have to get the exact same thing. We did. Okay, so these are applications of definite integrals. And we're also asked to find the same thing. I'm just going to, in part B, so I'm going to write for between 2015 and 2020. So this is between 5 and 10. Okay, from the same function, from m of t dt. So since we're here and we have everything right here, I'm just going to change this to 10 and this to 5 and get the answer. Okay, so this is 136 per thousand people. Divorces per thousand people. Okay.
How you copy the question?
Like this, second and copy.
Okay.
So you can go back and yes. So again for math, you click on math and you choose number 9, and this will pop up. You know what I mean? I didn't mean to put it in there. Okay. Good.
Thank you.
Thank you. Good. I would like to start. We have. Let me see. Where is my time here? Yes, that's perfect. I would like us to start chapter 5. Section. There are only 2 sections in chapter 5 that we are looking at. We are looking at 5.1. So chapter 5, only 5.1 and 5.7. I consider 5.7 the most involving section of this course. Okay, so let's go back to something called in 5.1. 5.1, these are applications of integration now, right? That's why chapter 5 follows chapter 4. In chapter 4, we learn how to integrate definite and indefinite integrals, right? And what they mean. The definite means an area. The indefinite means a family of functions. The most general antiderivative. So now the first application that we are going to look at, the second one is in 5.7. So 2 applications of integration, 5.1 and 5.7. In 5.1, we're going to look at something called consumer surplus and producer surplus. Okay. Okay, so first let's refresh our memory on those graphs for consumer surplus, for demand and supply, that's what I meant to say. So demand and supply. Okay, so I'm going to graph 2 functions. So let's start with this one. And here we have number of units. And here we have price per unit. Okay. So this is the demand function. How come? As the price decreases, we can afford to buy more units. As the price increases, we can afford to buy less number of units. So it's a decreasing function. Price per unit, function of number of units. We're not manufacturing anything. A number of units we can afford to buy. Let's suppose we have a particular point. It could be the equilibrium point or any point. And here I have number of units. Let's call it A. And here is the price. Let's call it B. Okay, so is there a way of determining this area? I'm going to call this function demand of x. X being number of units and demand being the price per unit. So D of x is the price per unit and x is number of units. So is there a way of determining this area? Yes. So this area can be easily determined by the integral from 0 to a from d of x times, of course, dx. Very easy. What does this area represent? The area represents the total consumer expenditure and surplus. Total consumer expenditure. This is the expenditure. And surplus. Here's the surplus. Okay, let's analyze what this means. So for this number of units, I will pay B per unit, and this product, A times B, is my total cost, my total expenditure. So if I buy 3 units at the price, to make it easy, 3 units at the price of $3 per unit, the area is 9, and this is what I pay, $9. If I buy 10 units at the price of $4, 4 times 10, this area is $40, and this is what cost me. Those 10 units at $4 a unit. That's what I pay. Now, what is this area here? What is the surplus called consumer surplus? This is something added in terms of money. I am really paying this. Let's say 3 times 3 to make it easy. I'm paying 9, but actually I'm getting a little bit more for my money than what I just paid for. And that's the surplus. I do actually pay $9, 3 times 3, 3 units, $3 a unit, but I'm actually getting a little bit more. This is the area. Once I determine this, I'll tell you exactly how much more I got. How do I determine the consumer? Yes?
So the expenditure is how much you're paying for a product,
Yes,
but the surplus is like
something added that I don't pay for. Exactly.
okay.
It's something called utility, something a little bit extra that I'm getting that I'm not paying for. So this is, for example, for 3. But what happens, I'm going to graph the same thing. I don't want to put it over there. So what if I have this and I pay, I'm going to say $10 units at this price, let's say $2 per unit. So I'm paying this. This is what I pay. Pay $20. 10 units at $2 per unit, I pay $20. But look how big this area is. A lot. of surplus. I'm not saying to you go out and buy 2 or buy 10 cars because you're going to have a lot of surplus, some value added. You're going to enjoy more. No, I'm not saying that. I'm only saying that this area is something called consumer surplus. Here, it's a smaller area because I only buy 3 units and the price is 3. But here, when I buy 10 units, the price drops and I have more to enjoy that I don't pay for. So we are interested in determining that consumer surplus.